The outboard motor. Introduction. Outboard motor for a boat are developed as a self-contained unit with engine, subsidiary systems, and propeller, designed to be mounted at the stern, rear, of the boat. They are the most common motorized method of propelling small watercraft. At the end of this topic, trainee will be able to identify the main component of the outboard motor. Model of outboard motor. Here are some models of outboard motor in Royal Malaysian Navy. Yamaha, Suzuki, Avinrude, Mariner, Johnson. Main component. Outboard motor. Fuel tank. Remote control. Outboard motor. May not exactly as shown, also may not be included as standard equipment on all models. Top cowling. Cowling lock lever. Oil drain bolt. Anodes. Anti-cavitation plate. Trim tab. Propeller. Cooling water inlet. Anodes. Trim angle adjusting rod. Clamp bracket. Tilt support lever. Power trim and tilt switch. Flushing device. Warning indicator. Gear shift lever. Tiller handle. Throttle friction adjuster. Engine stop button. Steering friction lever. Transom clamp handle. Rope attachment. Tilt lock lever. Flushing device. Starter button. Fuel tank. If the models was equipment with a portable fuel tank, its function are as follows. Fuel hose joint. This connector is provided for connecting and disconnecting fuel hose. Fuel tank cap. This cap for filling fuel. To remove it, turn it counterclockwise. Air vent screw, which must be loosened to vent the tank when operating the engine. Ensure the breather screw is fully closed when transporting the tank, to prevent spillage. Fuel hose. The fuel line connection to the tank should be self-locking, and the connection to the motor should be either the quick release type, or automatic shut-off type, when the fuel line is disconnected. Primer bulb. A priming bulb is built into the fuel hose head. Connect the fuel tank to the outboard motor. Before starting the engine, squeeze the priming bulb until it feel firm. This ensure that fuel is supplied to the engine. Remote control. Both the shifter and throttle are actuated by the remote control lever. In addition, this control also has the electrical switches. Remote control lever. Moving the lever forward, the neutral position engages forward gear. Pulling the lever back from neutral, engages reverse. The engine will continue to run at idle, until the lever is moved about 35 degrees. Moving the lever farther, open the throttle, and the engine will begin to accelerate. Neutral interlock trigger. To shift out the neutral interlock trigger of the remote control lever, must first be pulled out. Neutral throttle lever. To open the throttle without shift onto either forward or reverse, place the remote control lever in the neutral position, and tilt the neutral throttle lever. fully open, fully closed. Main switch. The main switch control the ignition system. Its operation is described below. Off. Electrical circuit switch off. On. Electrical circuit switch on. Start. Start motor will turn and start engine. Engine stop lanyard switch. The lock plate on the end of the lanyard must be attached to the engine stop switch for engine run. The lanyard should be attached to a secure place on the operator, fall overboard or leave the helm, stopping the ignition to the engine. This will prevent the boat from running away under power. Power trim and tilt switch. The power trim and tilt adjust the motor angle in relation to the transom. The power trim or tilt switch is located on the remote control lever grip. Pushing the switch up, trim the motor up, the tilt up the motor up. Pressing down, tilts the motor down and trim the motor down. The outboard motor operation. Introduction. The engine is one of the most necessary parts of the boat. Outboard motors are the most common type of propulsion used on boats today. This motor is mounted to the stern end of the boat, with an attached propeller in the water. There are many choices and considerations needed when it comes to purchasing an outboard motor for your boat. At the end of this topic, trainee will be able to describe principle of outboard motor operation. The outboard motor engine. The first practical outboard motor was created by Norwegian-American inventor, Olav Inrud in 1909. Most outboard motors are petrol-driven, two-stroke engines, although four-stroke engines are becoming more common. Two-stroke. The smallest gasoline engines are usually two-stroke. They are commonly used in outboard motor, high-performance, and small-capacity motorcycles. The two-stroke engine employs the crankcase as well as the cylinder to achieve all the elements of the Otto cycle in only two strokes of the piston. Power. Ignition forces piston down cylinder and rotates crankshaft. Exhaust. Exhaust port expels exhaust gases. Intake. Fuel and air mixture enters the cylinder. Compression. Fuel and air mixture is compressed by piston. Fuel system. Portable fuel tank. Portable fuel tank for outboard motors are fitted with a manual priming bulb. It is squeezed a few times to draw fuel when first starting the engine, or to continue to provide fuel to the engine in case of fuel pump failure. Care must be taken to ensure that the bulb is not over-squeezed, as this may cause leaks in the fuel system, or flood the engine with too much fuel, making it difficult to start. The bulb should be squeezed only until it becomes firm. Fixed fuel tank. Fixed fuel tank will sink to the lowest level of its surroundings, accumulating at low level in places such as the cabins and cockpits of boats. All fuel components must be in good condition. They must also be fire resistant, suitable for the fuel being used, and keep away or shielded from sources of heat. Cooling system. The internal temperature of spark ignition engine is over 3200 Celsius. Therefore, the motor must be cooled. Outboard motors are cooled by water. Internal lubrication system. 2- and 4-stroke engine differ in the way that lubricating oil enters the cylinder. In a 2-stroke engine, oil is added to fuel in the tank itself. However, some 2-stroke outboard engine have two tanks, one for fuel and another for oil. Lube oil tank. Fuel filter. Carburetor. Fuel pump. Oil injection pump. Mounting an outboard motor. Hand tie and screw thread clamp. Mounting bracket. Trimming the outboard motor. On smaller outboards, the trim angle is adjusted manually by moving an adjusting rod to different holes in the mounting bracket. The bigger outboard usually have a trim switch fitted on the remote control lever. Bow up. When the boat on the water surface, a bow up attitude result in less drags, greater stability and efficiency. This is generally when the keel line of the boat up about 3 to 5 degrees. When trim out, the boat may have more tendency to steer to one side of the side. Compensate for this as you steer. The trim tab can also be adjusted to help offset this effect. Too much trim out outs the bow of the boat too high in the water, and a boat may porpoise, hop in the water, which could throw the operator and passengers overboard. Bow down. When the bow of the boat is down, it is easier to accelerate from a standing onto water surface. Too much trim in causes the boat to plow through the water, decreasing fuel economy and making it hard to increase speed. Operating with excessive trim in at the high speed makes the boat unstable. Resistance at the bow is greatly increased, heightening the danger of bow steering and making operating difficult and dangerous. Optimum angle. Correct angle for the top performant. Tilt up and down. If the engine will be stopped for some time, or if the boat is moored in shallows, the engine should be tilted up to protect the propeller and casing from damage by collision with obstruction, and also reduce salt corrosion. Caution. Before tilting the motor, follow the procedures under stopping engine. Never tilt the motor while engine is running. Severe damage from overheating can result. Troubleshooting. Introduction. A problem in the fuel, compression, or ignition system can cause poor starting, loss of power, or other problem. This section describes basic check and possible remedies. At the end of this topic, trainee will be able to identify the steps in troubleshooting to rectify a problem. Engine fails to start. Check level of fuel in tank. Check air vent screw on tank open. Check arrow on primer bulb to ensure fuel line is connected the right way. Check fuel lines connected tightly and bulb primed. Check engine is neutral and throttle control in start position. Inspect battery and connection, electric start. Check emergency stop, kill, lock plate connected correctly to switch. Inspect fuel filter, fuel tank, external, internal, and clean if necessary. Check internal fuel filter to ensure filter casing is tightly screwed. Inspect spark plugs and clean if necessary. Check fuel pump to ensure membrane is not torn out. Check carburetor to ensure that draining screw is not opened. If engine starts, but stops almost immediately, check choke has been pushed back in. The close position enriches the fuel mixture for starting a cold engine. The open position provides the correct fuel mixture for operation after starting, and for restarting a warm engine. Redo check 1 to 12 above. If engine starts, but stops when gear is engaged. Check propeller is not blocked. Tilt up the outboard motor and carry out visual inspection. Turn the propeller to ensure is free and nothing obstacled object. Inspect spark plugs and clean if necessary. If engine still fails to start, seek mechanical advice. Engine overheat. Check water pump and thermostat operating correctly by check if telltale water stream is at normal rate. Inspect clear water intakes, plastic bags. Check oil level if separate lube oil tank is fitted. If problem cannot be rectified, seek mechanical advice. Electrical faults. Check for loose or dirty battery connections. Check electrolyte in battery at correct level. Check level of charge of battery with hydrometer. Check switch is connected correctly. Inspect spark plugs and connections and clean or replace if necessary. If problem cannot be rectified, seek electrical advice. Engine has been submerged. If outboard motor mounts are not checked regularly, the engine can shake loose and fall overboard. The safety rope or chain should be short enough to prevent the engine going underwater. If these measures are not followed, you will have to deal with an outboard motor which has been fully submerged. Servicing after submersion. Remove engine cover and rinse power head with fresh water. Disconnect spark plug leads and remove spark plugs. Disconnect fuel lines from engine. Drain and clean all fuel lines and fuel tank. Place engine in horizontal position, spark plug openings down, and work all water out by slowly rotating flywheel about 20 times, or until there is no sign of water. Drain carburetor, place engine in upright position and remove carburetor for disassembly and draining. Disassemble, clean and flush the starter, electrical connectors and all electrical equipment with fresh water. Then, tread them with a water displacing electrical spray and thoroughly dry them before assembly. Inject outboard lubricant into spark plug holes. If engine shows evidence that sand may have entered it, sand under the engine cover, or a slight grinding, or scraping when the flywheel is rotated, do not attempt to start the engine. It must be disassembled and cleaned. Reassemble the parts, start the engine and run for 30 minutes in fresh water. If engine fails to start, remove spark plugs again and see if water is present on electrodes. If so, blow out water and reinstall or replace with new plugs. Repeat starting procedure.